I would love when we get to a space where we don't have to think of people with disabilities as another category, right? I mean,
medicine has not been able to cure me, so I rely on technology to help me communicate and live. Over these years, the world, and technology's impact on it, has changed dramatically. Technology has changed the way we all live our lives, from communication to genetic research, access to information, and much, much more.
really amazing. Intel has had a relationship with Professor Stephen Hawking for more than 2 decades now. And it really started when our co-founder, Dr. Gordon Moore, met Professor Hawking in some event. And he promised him then that Intel will support all his computing needs for his entire life. So because of this existing relationship, about 4 years ago, Professor Hawking reached out to Dr. Moore again and asked him if there's anything that Intel can do, not in terms of just bringing a new machine in, but to really help him change the way that he communicates. He wanted something that looked and felt similar to what he had. And he was using a very old system, so there was a lot of room for innovation. You can think of it as a system that's made up of 3 pieces. The first piece is actually the sensor, which measures some movement from Professor Hawking. And in this specific case, he had the proximity sensor that sits on his glasses. And every time he moved his cheek, the proximity sensor will trigger, and that signal will get sent to a software platform that's running on his Windows machine. The second piece is the software platform, and that is a system that is called Easy Keys from a company called WordPlus. And basically what that system does is it acts like a conduit from the sensor to Windows, right? So it has a virtual keyboard, it has a mouse simulation, right? So he could go and start typing through that virtual keyboard through a timed interface. So you can imagine, a cursor going through the different letters, and once the thing gets on the letter of interest, then he can move his cheek, it will trigger that letter, it will type that letter into the thing. And there's, a word prediction, so if he types enough letters of that word, you'll see the word show up in the word prediction. He can go and select that one, again through a timed interface, and finally, once he's written everything, he can, just trigger the speech synthesis system. And the speech synthesis was really interesting because this is a hardware voice, which is really what Stephen came to identify with as his own voice. Stephen uses his machine just like any of us, right? I mean, he writes lectures, he presents lectures, he surfs the web, he, answers emails, he does all of these things. So when we started to actually really watch him as he did each and every one of these tasks, we realized that it took a very long time to do any of these things. Because right now, the mouse simulation is he starts going down until he gets to the line of interest, then he will trigger the sensor. And then it starts going this way until it gets to that point, then he triggers the sensor. It's a very slow process. We were looking, for example, for really improving the word prediction. Because if you think about it, he's saying he doesn't want to change the layout of the keyboard. So now, if you want to get faster without changing the layout of the keyboard, the only other thing you could do is type a less number of letters. That would translate into a speed up. He can just start typing, and even you could predict the next word just based on the context of the previous word without even having to type any letters of the current word, right? Because people are very predictable. So if you adapt the system to their language, you can guess quite well what they would say next. Stephen was a very active member of the development team, I would say. The development and the validation. It was pretty amazing, actually. So he, from the beginning, the approach that we've taken was an iterative design approach. So even before we started building anything, right, we would design things on paper, in PDFs, right, and send it to him, right? We would meet with him and we would talk through, here are the different options. Every time we designed something, he gave a lot of feedback. Even on things like the menus and the way, what items were being expedited within the menus, all of these different things. It's like he gave very specific feedback on. And of course, every time he used it, he would find a bug. So he was in the validation process too. So what we decided to do is essentially build kind of an open platform that allows us to bring different types of innovation in. And that essentially will have the advantage of allowing, applicability to other users. So for example, one of the patients that we worked with, she could actually move her finger. She couldn't press a button. It didn't have enough force, but she could slightly move that finger, but her face didn't really move. So then within the span of a couple of weeks, we were able to build a ring based on like an accelerometer that can detect that and then plug into exactly the same ACAT software that we had, right? Within a couple of weeks. I mean, it took just literally 2 weeks to actually move that to support a completely different type of an interaction. And so we put out essentially the complete system as a binary, on the open source, right? So even if you're an end user, we created all the documentation that was needed so people can just download it, download the sensor, try it out. And it was amazing. I mean, the number of people that came back to me and told me that, yeah, they could actually trigger the thing from the camera, right? They can use the system as is. Any person who is building any technology that is relevant, whether it's a word predictor or a sensor or whatever it might be, they can bring their innovation to the market very quickly, right? Because all they need to do is really bring that part, integrate it into the system, and now they have an ability to go impact a lot of people. We all have certain sets of constraints, and how do we create technologies that comprehend these constraints and literally change the world to become one of, right, there are very personalized experiences for everybody, and everybody gets their own version of a personalized experience through this advancement of sensing and sense-making and adaptation and really smart AI and machine learning technologies. And once we do that, then we can start to think about the world as, I want to create a personal experience for everyone. Not, there's people with disability, and then there's the rest of us.